So we're going to go page by page. Whatever questions you guys want to go over, we'll do those. So starting on the first page, the first objective of the year, which of these you want to see, do, go over? 2. Any others? Okay, so we'll start with 2. The goal with all of these is to get the variable by itself. So here we have to get rid of 19. How would we do that? How do you get rid of 19? Multiply. And then multiply 11 and 19. Someone tell me what that is. 209. Right? And remember that you can always go back and put it in. So put in 209 over 19, you should get 11, and that would be the way to double check yourself. For number 4, we have to get x by itself. So again, we're getting rid of the 19. What would we do there? Subtract the 19 on both sides. Subtract that from what you get. Again, if I wanted to check myself, I could put in 15 plus 19, and I should get 34. 5, we have 2 variables, so we need to combine our like terms, do exactly what it says, 4n minus 4n, but they cancel. So then we get a 0 equals 0 situation, and this would be infinitely many solutions. No matter what number you put in there, they'll always equal the same thing. Questions so far? In number 8, what would we do first? So distribute the parentheses. So we get positive 4 plus 28x minus 4x equals 4 plus 7x. And then what?
Subtract 4x.
Okay, so combine our like terms, do exactly what it says. We have 24x.
Subtract 7x.
And then you have choices. So you could subtract 7x if you want to do something else, that's fine. Taylor said 7x, so let's do that one. Let's also do the 4 at the same time. So subtracting 4 and subtracting the 7x. This side would completely be 0. What would the other side be? And then divide. So if you get something equals 0, that doesn't mean you stop, keep going. 0 can be an answer.
Is there ever like a no solution?
Could be. if your variables cancel and you get two different numbers. Number 10, similar to 8, but now we have parentheses on both sides. So distribute on both sides. We have negative 24n minus 24 plus 6 equals 4 minus 24n plus 2. Combine all your like terms on both sides. So combine all your like terms on one side and then on the other. Yep, combine 7. Okay, and then what do we want to move first?
Add 24.
Which means we would be, let's say I moved it from here to here, moving the 6. But our ends would completely cancel, so the no solution we were talking about, that would be this one. Our variables we don't have anymore. These two numbers do not equal each other, so this is no solution. Question so far? We'll go back and do 7 and then go on to the next objective. So similar to the ones we just did, distribute. So 3 minus 6 minus 36r equals 28 minus 5r. Combine like terms on the same side if you have them. So in this case, 3 minus 6. And then what do we want to move? So add 3 to both sides, and in the same case, we can move 5 to the other side by adding it. So negative 31r equals 31. And divide. What does r equal? Negative 1. Go on to the next page. Now we're at literal equations. It's like solving an equation, but there are no actual numbers, so they're all variables. Which of these do we want to see to go over and review?
11.
Someone said a different number. do those, and then if we have more, we'll do those as well. So starting with 11, we have to focus on what we're looking to solve, which in this case is A. So we have to get A by itself, get rid of everything else. What do you think we would get rid of first? M or the B? If we were to get rid of the B, we have to divide it somehow, which means it would end up where M is. So that wouldn't really help us. So we could get rid of M by doing what? So remember, in this case, you're still going to have the variables. They don't just disappear. On one side, they may disappear, but they're still on the other side. So we have MZ equals AB. Now, if we were solving this like a regular problem, how would we get A by itself? So again, they disappear on this side, but it's still on this side. So A equals MZ over B. If I had values to each variable, then I could figure out what that actually is, but I don't, so that is my equation. Questions on that before we continue? Well, we're trying to get x by itself. It's in the denominator, so we would need to get it out of the denominator before we could do anything else. So it's going to seem like we're not really getting x by itself at first. So just like here, we have to multiply both sides by x. But when we do that, I would put x outside of parentheses. And then we still want to get x by itself. We don't want to distribute because that wouldn't get x by itself. But we could get rid of this entire thing by dividing it to the other side. So our equation would become k over w plus v equals x. Any questions about that? Great. 13, we're trying to get A by itself. What would we do there? Divide both sides by C. And this one, that's all we need to do, just that one step. So A equals R minus D all over C. Okay. In this case, it looks complex because of the fraction. You're subtracting, you're adding, but we're still just getting rid of getting x by itself. So how would we get rid of C? Subtract it. And you're just going to subtract it to the other side. So you could rearrange it if you want. Negative C plus y minus d over r. You can put the C at the end, in the middle. But you don't need to do anything more. It just looks complex.
And you can do y minus d over r minus c.
Any of those will work. There are more complex things, but I'm going to just leave it at that. And then the last one, we have to get x by itself. In this case, we have to think about this like I could make this into a fraction. And if we have a fraction that equals another fraction, we usually cross multiply. So I'm going to do that and rewrite it. A plus x, I don't really need to put the times 1, equals u times w minus v. And then I could distribute the u, I don't need to distribute the u, either or. And then how would I get x by itself? So x equals u times w minus v minus k. If you wanted to distribute, you could also do that. You could put the minus k in the front. It doesn't really matter. Are there any other questions on this page that we want to see to go over? So for 19, we do have a little bit more that we have to get rid of because we're trying to get x by itself. What do we think we get rid of first? For 19. If you divided, you'd have to divide everything by c. So you could do that, but then you'd end up with a lot more fractions than you might want. Yeah, you can really do that at the same time. So let's say I put it in ABC order. G plus D, that would not be the right order. D plus G plus R equals CX. The order on that left side doesn't really matter. As long as you can tell that you're adding all three, then we could divide both sides by C. And then we end up with just one fraction instead of 3. The only way to really check these is if you give each variable a different number and put it into the calculator and see if it works. That's a lot more work than you might do. Go on to the next page. So now we're in the second unit. First objective of that was slope. So that's from a graph, from 2 points, from an equation. Which of those do we want to see go over? We'll start with those, and then if we have others, we could do that. So find the slope of the graph from each line. You have to find 2 points on this line that cross the background grid lines exactly. So points would be like where the arrow ends. There's another point here, another point here, and right before you get to the arrow at the bottom. So you can choose any of those points. We really just need 2. And then we're counting in between. Rise over run. So go up or down before you go left or right. If we go up or down and then left or right, how many units does it take to get from one point to the next?
3 up, and 1 to the right.
So if you're going this way, you're going up 3 and to the left 1. You could also look at it the other way and go down 3 to the right 1. Either way, one of those directions has a negative, the left or the down. So we would simplify that and say it's negative 2. If I'm going left, that's a negative. If I'm going down, that's a negative. So depending on how you look at it, it's going a negative direction either way. 22, let's find more points that cross these grid lines exactly. Looks like 1, 1 is a point, and maybe 4 or 5. And then negative 2, negative 3. And then do the same thing, count up or down, and then left or right. What would that slope be?
4 up, right 3.
So if we're going up 4 and right 3, those are both positive directions. So this is going to be a positive slope. And it can't simplify, so just 4. Okay. Questions on that one? (24), you can do the dots, but if you remember your toy bucks, that will also make this easier. So horizontal lines have 0 slope. Vertical lines have undefined slope. I skipped the y equals and x equals. We don't need that part for this. So is this a vertical line or a horizontal line? So that means the slope would be undefined. That's supposed to be an arrow. If you wanted to do it with just the dots, you could find any 2 points on this. And the rise between these is down 2, but there's not any run. And if you put that in the calculator, you get error. And that's how you know it would be undefined. Other questions on those? (27) is already in slope-intercept form. Your y equals mx plus b. M is your slope, so whatever that number is your slope. So not the x, but just the number. Are there any others on this page you want to see to go over? Did you make the pass already? Okay, so let me know when the pass is made. For 26, if we're given a pair of points, we need our slope formula. y2 minus y1 over x2 minus x1. If you forget the formula or how it goes, try to remember at least that the y's go on top is your rise over your run. If you forget the order, as long as you put them both in the same order, it doesn't matter. I got your final exam review. You could label these if you want to, if that helps you. And then put all of these into that formula. So y2 would be negative 18. y1, we are subtracting no matter what, but this also is negative. So you would put both minus negative. x2 is 3, x1 is 2. And then you would subtract that and see what you get. You could put this all into the calculator at the same time or do it individually, do the numerator and then the denominator. Either or doesn't matter. What would this numerator give us? 0. Denominator would give us 1. And 0 over 1 would be what? What would this simplify to be? Not 1. 0. In this case, we also could have known that it was going to be at m equals 0 because of the y values. They were the same. So if your y values are the same, they're going to fall on a horizontal line, so your slope is going to be 0. Opposite would be true if there were x equals. Any others on this page that we want to see you go over? Go on to the next page. Now we're in writing equations of a line. So from a graph, from a point and a slope, from 2 points, from given slope and y-intercept, all of those things. So which of these do you want to see if you go over? Those of you not paying attention, I don't expect to see you in my office hours asking about these questions. Any others? We can start with those two. So write the slope-intercept form of the equation of a line. look for your y-intercept. Where does it cross the y-axis? And then find another point where it crosses the grid lines exactly. So you have multiple choices. There's a point here at 1, -2, another one at 2, 0, another one at 3, 2, another one at 4, 4. Any of those would work. Now we need to count the slope. So rise over run, how far did we go up or down, and then left or right. This is 2 over 1, so just simplify that to this 2. So then write your slope-intercept form, y equals mx plus b. So y equals 2 and then x, and then your b in this case would be -4. We don't need it to be positive always. Questions on that one? Is the same. Find your y-intercept, find your slope. The y-intercept we have at 1. For your slope, look for other points that cross the grid lines exactly. And be careful because it looks like it for some of these, but not everywhere. For certain at -5, 4 and 5, -2. What would that slope be? Okay, so then how would we put those two things together to write it in the equation? What would that look like? Y equals what? Wherever it crosses the y-axis. Any others on this page we want to see do go over? You're given your slope-intercept, your slope and your y-intercept. So you would just kind of do the same things we were doing before. Put those together in your equation. Y equals -1x or -x, and then -4. Either of these would be fine. Either putting the -1 in front of x or not. You have to rearrange this, solve this for y before we could figure out what the slope-intercept form is. So think about this like your literal equations, but now we're solving for y, trying to get y by itself. How would we do this? what would we get rid of first? Subtract it to the other side. And then to get y by itself? But we're going to do that to everything. So separately. So these would cancel. The negative x over the negative 6, you can rewrite that. Bring the fraction in front of the x, and it would become positive. And then divide negative 6 and negative 6. Again, would become positive. Questions on that, or any other questions on this page? If no other questions on this page, go on to the next one. Now we're at graphing. And you're either going to be given slope-intercept form and you graph the line, or you're not and we'll have to solve for y and then graph the line. Which of these do we want to see to go over for you? So, any others? 48. Okay, let's start with 43. This one is not in slope-intercept form, so what would we do first to start to get y by itself? Similar to what we did to the last one on the writing page, but now it's just connected to a 3.
Subtract.
Yeah. So still subtract it. Just think about this as one whole thing. So negative 2y equals negative 3x minus 4. And then do what? How would we get y by itself?
Right, negative 2.
To everything. So in this case, y equals this would become a fraction because it's not going to simplify nice, but the negatives would go away. Here, this would simplify and the negatives would become a positive. Then we actually have to graph it. So look at your y-intercept first. Start there, put a point at positive 2 on the y-axis. And then use your slope. And go up 3 and to the right 2 since it's positive. And we can also do the opposite. Go down 3 and left 2. Because even though those are both negatives, 2 negatives make a positive, so it would still be positive. And do that as many times as possible. And once you have enough points to fill up your graph, connect all the dots and make a line, draw arrows at the end. questions on that one? If at any point while we're doing the review or on the final you need rulers with colored pencils, those will still be back there, so you can still use those. 46, it's already in slope-intercept form, so we don't have to do the work to figure that part out. We just have to graph it. So start at your y-intercept, which is -5. So on the y-axis, plot a point at -5. Your slope is again positive. So we can go up 1 to the right 2 as many times as possible. And then we can also do the opposite and go down 1 and left 2 from the y-intercept. And once you have all your points, connect the dots, make a line, draw arrows again. And then 48 is very much the same. It's already in slope-intercept form. Start at your y-intercept, -2 on the y-axis. What's your slope in this one? -1. So you have to think about that like -1/1. And to make it negative, only one of the directions can be negative. So I can go up and to the left as many times as possible. 1 up, 1 left. And plot a point at every up 1, left 1. Or I can do the opposite and go down 1 and to the right 1 from the y-intercept. And plot a point at every down 1, right 1. And then draw a line through all those points. And make sure you have arrows again. For 47, because this is just an x equals, we have to be thinking toy bucks. Because this is an x equals, this is going to be a vertical line. So find when x is -3 on the x-axis, put a point there, and draw a vertical line up and down through that point. Other questions on this page before we move on? Go on to the next page. This should seem familiar to you as we just did this when we reviewed our intercepts, where you're either finding intercepts from a graph, from an equation where you have to solve. Which of these we want to see you go over? Any others? We'll start with those. Here we are given graphs, so we just have to find where does this line cross the x-axis and the y-axis. And then write those as ordered pairs and label which one is which. So on the x-axis, it crosses at 3. on the y-axis, it crosses at 2. So those ordered pairs would be 3, 0, and 0, 2. Questions on that one? (52) is the same. Look for where does this line cross the x and y axis, and label them. X axis, it would cross at -4. Y axis, it would cross at -2. So -4, 0, and then 0, -2. Other questions on this page? Go. Okay. So then for these, we have to solve them in order to find the x and y intercepts by putting 0 into one or the other, not at the same time. So if I'm solving for the y-intercept, I'm going to put 0 in for x. The 2 times 0 is just going to become 0, so I don't need to bring that part down. It's going to disappear. And then I'm just solving for y. So that y equals 2, and I would rewrite that as an ordered pair, coordinates, ordered pair, something. And I know my x value is 0 because that's what I put in. And then you would do the same thing for the opposite. So instead of putting 0 in for x, we're now going to put it in for y. And solve for x. So the 3 times 0 would become 0. We don't need that part. And then we could solve for x, divide 2 on both sides, and write that as an ordered pair. Questions on that before we do 55? Is the same. So it does not matter which one you do first. I'm just going to keep doing x first. We put 0 in for x and then solve for y. Divide both sides by -9. So we get -4. And then write that as an ordered pair. 0, -4. And do the same thing to find y. To find x, sorry. So put 0 in for y and start to solve. Divide both sides by -3. And then make that an ordered pair. Have any questions on that or any other questions on this page? Go on to the next one. So we are now in in marking period 2. Second part of this parallel and perpendicular lines, which again should be familiar because we just reviewed these. Which of these do we want to see? Do you go over and review? So, we said 59 and 58. So the first section, you were finding the slope that's parallel. Side note, I'm going to put over here. Parallel lines have the same slope. So they have to be exactly the same, but different y-intercept. If we were writing the equation, but this first section doesn't ask for that part. So for 58, what would the slope that's parallel to this be? If it has to be the same. $59, we have to solve first before we can figure out what the slope is. So subtract x on both sides. Divide everything by -5. We get y equals, this becomes positive 1/5 x minus 4. And if the slope is parallel, what would that slope be? What would that slope be in this parallel? So if it's parallel, same slope. If it's perpendicular, you need the negative reciprocal. Which means whatever it is, you take it, you flip it. If it was positive, you make it negative, or vice versa. So 61 is already in slope-intercept form. If we took this slope and flipped it and made it negative, what would that new slope be? So then 68, I think, was the next one, and then if we have any others, we'll go back to these. Right, so now these want you to write an equation that's either parallel or perpendicular through a given point. So we need this equation. I'm going to write this here. Y minus y1 equals m times x minus x1. And then for 68, we have to find our slope. We are given our x1 and y1. So it's going to be perpendicular to this equation. What would our new slope be? just simplify it to just 3. So you really don't need any of that once you have it, once you have that new slope.
Why isn't it negative?
It was already negative. So you take it, flip it, and make it positive if it's negative. Okay, so we're going to use that slope and that point in that formula from above. Y minus our y1 is 5. Remember, we're always subtracting even if our numbers are positive. Equals 3 times x minus 3. And then our goal is to get it back in slope-intercept form. So we're going to distribute. What would we get when we distribute? You can sleep, you're just home. What would that be when we distribute? 3x minus 9. And then we would add 5 to both sides. So then this would be the equation that's perpendicular to the original. If you change the slope later, like keep the same slope but then use all the same numbers here and then just change it at the end, you won't get the right thing. Are there any other questions we want to see do go over? 65 and 67 are similar, but different. So if it's parallel to this, we could be thinking, what is the type of slope that an x equal has? If it's x equals, the slope of this line is undefined. If you have an undefined slope, you cannot do the work for it. So you have to know how to write your equation. If it's parallel, the slope is going to stay the same, so it's still going to be an x equals, and you have to look at your x value. So there's no work to really do for that one. You just have to know the slope, you have to know what type of equation it would look like, and then which value. Other questions on this page? So this would be kind of the same, but a little different. It's still going to be something where you're using l.o.b.f, except because it's now perpendicular, the slope of this line was 0, but we need it to be perpendicular, so it's going to switch. You need to think about the opposite. So now it's going to be an x equals, the slope is going to change. So we're no longer focused on the 0 slope. We don't need that part anymore. We need the undefined slope. So an undefined slope is an x equals, and you look at your x value. So again, there's no real work. There's just you have to know the types of slope, the types of equations, and how to find the value. Other questions on this page? Go on to the next one. now we're at linear regression. You won't be given the steps to this on the final, so you would just have to know this or skip it. We won't do multiple of these unless they're different types. So we could do like a year and one of the other ones, so like 72 and one of the other ones, and then we'll do the pieces. But which one do we want to do first? For this one, if you don't have your calculator, you'll need it because almost all of this work is done in the calculator. Now, this one gives us the equation, but not all of them would. So we're going to walk through the steps on how we would figure this out. In this case, you have to know which one is x, which one is y. Does the distance depend on the cost, or does the cost depend on the distance? Would it cost more the longer they flew? So then the cost would depend on the distance. Whatever depends on the other is your y. So like distance can't be changed, so that's independent, that's your x. So then in your calculator, you would put in these values. Let's reset our calculators first. 2nd plus 713. And then you're going to go into stat, go into edit, the first one, so 1 or enter. You're going to put all the x values in L1 and all the y values in L2. When you type in the numbers, you can either type them in and hit enter, or you can scroll down, hit the down button, either or. Stat, and then edit 1 or enter. And then if you reset it, there shouldn't be anything in here. But if you didn't reset it, go up to the top and hit clear. And then come back in. Once you have all of that in your calculator, you're going to go back to stat and scroll over to calculate. And then we're looking for linear regression. There are 2, but you want the one that looks more like your slope-intercept form. So number 4, you can either hit 4 or scroll down to 4 and hit enter. Make sure your X list says L1, your Y list says L2. Scroll down to store this and hit alpha trace and then enter 3 times. So again, it gave us this equation. We didn't really need to find it, but it'll help us now that it's stored. It would tell you how many decimal places to round to, but in the equation they gave us, they rounded to 3 decimals in the slope and then 1 in the y-intercept. Then we have to answer the questions A and B. What would the cost of the flight that travels 850? So that would be a distance, and we're looking for y. So we can do a couple different things. One would be to store your value as x as 850. I'm going to type in 850 from that same screen. And then type in STO. And then x. And then enter. So now my x value is now 850, but I want my equation to be solved with that value. So I'm going to go back and grab my equation, alpha trace, and we stored it in the first one, so enter, and enter once more. So that would give us the answer to part A, and this is round to the nearest dollar, so 1.52, 153, even though it's not enough to round it up, but we still have change, so still round it up to $153. If the storing is too much to remember, you could also go into your table, second graph. All the values from the equation itself, since we stored it, should be there. Instead of scrolling to 850, you can change where it starts. Go into second window. Tell it to start at 850. And then go back to the table, second graph. And you would get the same thing. Part B, you can either do by hand or do in the table. The table might be easier since it's already up here. We're looking for 4,800 kilometer flight cost. So we're still looking for y, and we have a new x. So we can change that x value to that. Second window, again, change this to 4,800. And go back to the table. And then to the nearest dollar, we can say $701. Did we want to do 72 on this one? So we'll do that, and then we'll be done for today. With anytime you have years, you have to change them. So whatever the first year is going to be 0. No matter what it says, it's always going to be 0. Every year after that is how many years has it been since the original. So starting at 2001 to 2006, 5 years have passed. Then not from these next two, but from the original still. So 2001 to 2007, 6 years have passed. 2001 to 2009, 8 years have passed. 2001 to 2011, 10. And 2001 to 2013, 12. So those will be the numbers you put into the calculator, not the 2001 and on. Anytime you have years, that's always X. So that means the number of marriage license would depend on the year. And then we're going to go back to stat and do this all over again. So stat, edit. You can go up to the top and hit clear and scroll down and do the same thing for the other one. And put in all those values. sure you don't miss any zeros. These are 1,000 numbers. Once you have all the numbers in, go back into stat. Scroll over to calculate. And then down to number 4. And then again, we're going to store this. So store alpha trace. And hit enter 3 times. The equation they gave us is different because they put in the years and we did not, so we would use this one. And then in order to answer part A and part B, we would need to figure out how many years have passed since the original. So in 2005, that would be 4 years later. And 2021, that would be 20 years later. So I'm going to go to the table and find both of those values. Second graph. Right now, it's still at whatever we were at before, so I'm going to go into second window and change this back to 0 or 4, doesn't matter. And then second graph. So at 4, it was 130,129. So I'll write that down, and then we'll go back and find the numerous. Since it says to the nearest 100, 130,000, 100 marriage license. And at 20, if I scroll down, $66,246 or 66,200. So we will stop there in the review for today. Friday, make sure you guys have your laptops, all of you, those of you sleeping too, because you're all taking the STAR tests. And then after that, you'll have time to finish tests, work on retake, work on Khan Academy, / work on final exam review. Remember that today is the last day to do objectives 5 and 6 if you want those replaced in marking period 3. Next Thursday is the last day to finish the test regardless. So make sure you're using that time wisely. Come see me if you need to work on those tests before that or want to do that today, tomorrow. Also, for next week, would we rather work on the review by ourselves or continue to have me up here? Okay, so those that would rather me continue to work them up here, raise your hand. That means we have to pay attention. I know you guys were, and I think